I'm astronomer Doug Duncan of the Fisk Planetarium at the University of Colorado Boulder. Welcome to Explorations, the series that takes a look into NASA's diverse projects and the people who make them happen. Have you ever wondered how the Earth formed? How our rolling plains, majestic mountains, and vast canyons came to be? The story is written here, in the rocks. Each layer you see tells a chapter of the Earth's past. The deeper you look, the farther back in time. But the earliest pages, the ones that tell of the Earth's formation, are missing. Wind, rain, snow and ice, volcanoes and tectonic activity have eroded them all away. To find even older rocks, we've discovered that we need to look up rather than down. "50 years ago, humanity undertook the most ambitious geological field survey of all time. Apollo astronauts brought back 840 pounds of moon rocks, pebbles, sand, and dust from 6 different landing sites, from the White Highlands to the dark Maria. Every year, about 400 lunar samples are shared with the world for teaching and research. These samples are valuable for telling the early story of the Earth and the Moon. How does one read a rock? By looking at the outside, scientists can tell what conditions the rock has endured, like having been smoothed by water. By looking at the inside, they can tell how the rock was made and what it's made of. Many of the moon rocks are breccias, you might say collages, of other rocks melted together by the heat of giant impacts of meteorites and asteroids that produce the moon's craters and the smooth, dark regions called Maria. If the rock has radioactive materials in it, scientists can use the material's decay rate like a clock to figure out the rock's age. Most moon rocks brought back by the Apollo missions are about 4 billion years old. Rocks from the lunar highlands are mostly feldspar, the white material in granite, mixed with a small amount of a mineral called olivine, a form of which, peridot, is the birthstone for August. Rocks from the dark Marias are mainly basalt, a rock formed by rapidly cooling lava that filled giant impact basins. Moon rocks contain little or no volatiles, chemical compounds that are easy to vaporize, like water. All this information taken together tells a remarkable story, that the moon formed from the Earth. 4.5 billion years ago, Earth was hit by a body the size of Mars. And the moon formed out of the resulting debris. Comparing the chemical composition of the moon rocks to those on the Earth supports this amazing scenario. It also explains why the moon rocks carry no volatiles. The collision and heat of the moon's formation vaporized them. The moon's formation would also have produced enough heat to melt the rocks, leaving the young moon a ball of magma. It might surprise you to learn that some rocks can be buoyant in lava. The heavier ones sank to form the moon's core, while the lighter ones floated to the surface. This happened when the Earth formed, too, with heavier elements sinking to the core and lighter ones on top. Many of the Apollo moon rocks come from the broken remains of impact craters. Radioactive ages of these rocks tell us that many craters formed all around the same time. All the terrestrial planets, including the Earth, went through this accretion and bombardment, but the only body where we have the evidence is the Moon, hidden in the rock. What's it like to study a moon rock? Let's ask Dr. Steve Moises of the University of Colorado, who has one in his hand.
You know, what's exciting about working with rocks such as these is that it was on the moon. And people went there and braved the conditions to pick something like this up and return it to the Earth for someone like me to study. So it was a profound feeling knowing that here is a piece of the moon in my hand. Indeed, we can pick out individual minerals, and there are techniques now that can separate atoms out of individual crystals and reconstruct the information inside that crystal, which is a kind of time capsule for the solar system. Well, just by looking at the moon in the sky, you can see that it has some history to it. There are dark patches and light areas and so on. And then when we investigate a rock such as this one, brought back to us from the moon, we find that that history is recapitulated in the minerals of this rock. Now, the moon is the neighbor of the Earth. So anything that has happened to the Earth from outside, like comets and meteors striking our surface, would likewise affect the moon. The difference is that the moon retains that information. Earth is very good at effectively recycling itself. The moon, on the other hand, is like the museum in our attic.
We'll be visiting that museum again and learning more soon when we return to the moon. On behalf of NASA and Fisk Planetarium at the University of Colorado Boulder, thank you for joining us for this episode of Explorations.